Okay, so now we're going to do number 6 through 10. On this example, it talks about do diets work? And I'm just going to summarize it. But there are 132 participants in this study, and they're randomly assigned to a low carb diet, and the other half are low fat diet. Researchers measure each participant's change in weight and cholesterol level after 6 months and again after 1 year. Explain how each of the 4 principles of experimental design will be used. We're actually only going to use 3 of them, and in the Zoom, I also made mention to this. There's 3 different principles of design that we're gonna focus on: control, randomization, and replication. So in this one, control, all patients considered obese and willing to participate in this one. So that's the control group, is that all patients are considered obese and willing to participate. So we're controlling it in that way. We're selecting the individuals that will actually be involved in it. Are randomized, we're gonna randomize half of them. So we're gonna randomly assign to the half of them to a low fat diet and then half to a low carb diet. And there's also just implied randomization in that. When they say half and half, there's implied randomization in this. Replicate, we're gonna replicate on all 132 volunteers. Okay, so the next one in number 7, we have Fizz Laboratories. A pharmaceutical company has developed a new drug for relieving chronic pain. 60 patients suffered from arthritis and needed pain relief are available. So 60 participants are what we're looking at. Each patient will be treated and asked an hour later about what % of pain relief did you experience? Why should they simply not give the new drug to 30 patients? The whole idea of that is for control. There needs to be a control group in every experiment for comparison. So there needs to be a control group for comparison. You need something to compare to. This is the idea of the placebo, okay? A placebo being implemented. In part B, it says, should the patients be told whether they are getting the new drug or the placebo? Because that's what you would do in this one. You would introduce a placebo to be able to compare the two against each other. Should they be told that? Well, no, that completely defeats the entire idea of a placebo. The reason for a placebo is because our brain reacts to getting a treatment in some ways. So because of that, telling them, hey, by the way, you're taking a sham treatment, that would actually completely null and void the reason for having a sham treatment. Okay. And plus the response is subjective. Just asking, hey, what % of pain relief do you have? If you told them you were giving them a placebo, they'd be like, well, none, right off the bat. Okay, so now we're gonna look at number 8. Number 8, it asks the same thing within this. So you have acupuncture and pregnancy. A study sought to determine whether ancient Chinese art of acupuncture could help infertile women become pregnant. 160 healthy women undergoing assisted reproductive therapy were recruited for this study. Half of the subjects were randomly assigned to receive acupuncture treatment for 25 minutes before embryo transfer, and again 25 minutes after the transfer. The remaining 80 subjects were instructed to lie still for 25 minutes after the embryo transfer. Results: in the acupuncture group, 34 women became pregnant. In the control group, 21 became pregnant. Okay, it says, why did researchers randomly assign subjects to 2 different treatments? Random assignment must be used because researchers may subconsciously select women that they think might get pregnant easier. More than likely, the people that are assigning the patients to groups are the fertility specialists themselves, and they might have prior knowledge about which women are going to have an easier time getting pregnant. Regardless of any study, we always randomly assign to take out any unconscious or subconscious bias that may happen. In B, the difference in the % of women who became pregnant and the 2 groups is statistically significant. Explain what this means to someone who knows little about statistics. Okay, it means that there is enough of a difference in the results to assume that it was from the experiment and treatments. So in this one, if the results were statistically significant, then it would mean that that acupuncture could increase pregnancy in women. Okay, statistically significant means that the results were too far different to just happen by chance. Okay, and C, explain why the design of the study prevents us from concluding that acupuncture caused the difference in pregnancy. This is not really a large enough sample in order to justify a cause and effect relationship. There's really not enough replication in this one. You would need to do a much larger sample with these individuals to really be able to get that cause and effect relationship. Okay, so the next two you're actually diagramming in 9 and 10, or I'm sorry, oops, I grabbed the wrong one. In 9 and 10, you are diagramming the experiments for each one of them. Remember, when we diagram, we still always have to come down here and explain the random assignment. So in 9, we have half workers. It doesn't tell us here how many are in each. At least that's what I have here. No, it does not tell us, oh, I have 50 workers to test on. So what I have to do instead is say half of the workers. I'm going to randomly assign half the workers to a 70% or 70-degree Fahrenheit working condition. I'm going to assign half the workers to a 90-degree Fahrenheit condition. And at the end, I am going to compare, and it's very important that you always say what you're going to compare. I'm comparing the number of correct insertions in 30 minutes. It says that very specifically. So look for that. Your compare always has to be within here. Okay. The way that I chose to do random assignment is place all workers' names in a hat, draw half in 70, and they get the 70-degree working conditions, and then the other half get the 90-degree working conditions. Looking at number 10, it's talking about energy conservation and allowing customers to either have like this chart that they can look at or a digital display. And so I've done the same thing. It did not tell me how many customers were going to participate, but I am going to randomly assign, and I just put half the customers and half the customers. And now that I have my groups, the first group is going to get the chart approach, and the second group is going to get the display approach. And at the end, we're going to compare energy reduction. That's very specific in there, energy reduction. Okay, our random assignment again, I might place all customers' names in a hat. I'm gonna draw out half and they get the chart approach, the other half get the display approach. I could number all the customers and then use the table, draw, you know, half of them chart approach, the other half get display approach. But that is how you're going to diagram your experiments.